Okay, we're going to work on graphing a tangent graph. This can really be applied to tangent or cotangent, but I'm going to give you some prompts along the way to kind of stop the tape, try some things on your own, and then start up the tape again to see if you can get it all. Over on the side here to the right, I got your standard tangent graph, your standard cotangent graph. You should be familiar with these by now. We use these as a reference when we're graphing bigger equations. Alright, so to get things started, let's first talk about, for this particular tangent graph, I like to base my graphs around the asymptotes. You don't have to do it, but that just seems like a very logical way to do it, because the graph between these two asymptotes is going to be one cycle. Technically speaking, the cycle goes from pi over 2 to 3 pi over 2 when we're looking at a tangent graph. Cotangent graph, one cycle would go from 0 to pi. So both of these have a period of pi. So when graphing a tangent graph, I like to figure out where the asymptotes are going to go, which means I'm going to set up an inequality here. Set up an inequality that's going to take me between pi over 2 and 3 pi over 2. Here would be a good place to stop. Try solving this thing on your own. Make sure you're familiar with it, and then start it up again to check yourself. My first step is going to be to multiply everything by 4. Multiply this by 4, multiply this by 4. I multiply the inside by 4. I guess I could put it up here. The 4 and the 1/4 are going to cancel out. So this gives me 2 pi here is less than x minus pi is less than 6 pi. And then I'm going to subtract, add a pi to everything. So from 7 pi to 3 pi. So this is where my asymptotes go. And it's important that you realize that, because when I set it up, here and here represent the asymptotes of a cotangent graph. Alright, I'll keep that in mind. The other thing that this thing has going on, it's got a vertical shift of 2 here. So I'm just going to make note of that, a vertical shift of 2, and it's got an a value of 1/2. I really can't call that the amplitude, because tangent graphs don't have amplitude. So we'll just call it an a value. Alright, so basically what I'm looking at, if I just want to graph one cycle of this thing, I got to bump this whole graph, this whole tangent graph has to be bumped up 2 units. And so this is going to be my arbitrary x-axis. I got an asymptote at 3 pi and 7 pi. I'll put 3 pi there, 7 pi there. So here are the asymptotes that are coming off this graph. This is going to be a midpoint of 5 pi. And the tangent graph rises from left to right. Mark this as a 2. We'll call this 2.5. Call this 1.5. There's the a value, the 0.5. In a tangent graph, it's really hard to figure out exactly what that a value does. But basically, I guess we could say it's the point where the graph actually starts going more vertical after that point. There's one cycle. If you wanted to continue, 3, 5, 7, the next point would be a 9 pi. The next point after that would be an 11 pi. I could draw an asymptote there and just do another cycle of this thing, which would be something like that. That's your tangent graph. If you want to make it a cotangent, how does that change things? Well, if this is a cotangent function and I want to figure out the asymptotes, instead of using pi over 2 and 3 pi over 2, I would look at my cotangent graph and say, okay, well, cotangent has asymptotes at 0 and pi. And so these points here, instead of pi over 2 and 3 pi over 2, become 0 and pi. And I solve it, find my new asymptotes, find a midpoint. The graph falls from left to right, and you're on your way. And that's pretty much it.